Good morning. Today we are working on PO16. I can add and subtract fractions. So we're continuing on working with those fractions. Imagine for a moment you're a zookeeper. I know it's a stretch, just bear with me. Oh, Mr. Schultz. Your zoo has recently gained a bunch of animals from a nearby zoo that was closed. Would you add lions to the pandas? Well, only if you want it to be a mess. So really, you would not want to put the pandas with those lions. Those poor pandas don't want to get eaten by lions. Would you add gorillas to the penguins? Of course not. Would you add tropical fish to the giraffes? Well, that would just be cray-cray. The same logic can be applied to adding denominators of fractions. So if you think about the zoo, you want to add lions to lions, pandas to pandas. With denominators, you want to add the same denominators. So when adding or subtracting fractions, there are basically two rules to follow. Denominators have to be the same. Our second rule is denominators stay the same. So we have to make sure the denominators are the same, and then when we're adding, they stay the same. So we only add or subtract the numerator. Denominator always stays the same. So think of the denominator as telling you what you have, and the numerator telling you how many of it you have. Would 2 chairs plus 3 tables equal 5 tables? That doesn't make sense. Just like 2 sevens plus 3 nines would not equal 5 sixteenths. So when we have that same denominator, we look at this first example, we're saying it is broken up into fifths. So we have our circle broken up into fifths. How many fifths do we have all together? So our denominator has to be the same, so we know how much it's broken into. And then if we're going to add them, we have 1 section plus 3 sections. We know that we have 4 fifths. That fifth stays the same. That circle is still broken into 5 sections. So the fifth always stays the same. That denominator stays the same. Our numerator is going to change. How many are we adding together? How many are we taking away? We're going to end with a different numerator, but it's still going to be out of the same denominator. So when that denominator is the same, it's easy. You just have to pay attention to, are we adding or are we subtracting? But your denominator stays the same. What important thing do we have to remember is always our final step? Melanie? Simplify, simplify, simplify. Always look to see, can I simplify my answer? So always look, can it be simplified? What gets tricky is when our denominators are different. So if I have 1/3 plus 2 fifths, what's the first step I have to do, Zelda?
It says for the first rule, denominators have to be the same, so you could find a common denominator for 3 and 5.
So what is a common denominator?
15.
15. So I can change it to be 15. I need to remember that I'm still adding. How did I go from 3 to 15? Kelly? I times by 5. 3 times 5 is 15, so whatever I do to my denominator, I have to do to my numerator. So 1 times 5 is 5. How did I go from 5 to 15? Madison,
What was it?
can you figure it out?
Like, how do I go back?
Yeah. What do I multiply by? Yeah, I'm going to multiply by 3. So 5 times 3 is 15. So then I have to do 2 times 3. 2 times 3 is 6. So now I can do my math. My 15 stays the same. That denominator will stay the same. Well, it's out of 15 sections. How many do we have altogether? We have 5 15s plus 6 15s. 5 plus 6 is 11. I cannot simplify it, so it stays 11 15ths. On the bottom, it has some questions that you need to be able to answer. What two fractions with different denominators add to be 9/20ths? So this one is something that tricks kids up a lot when we get to this. So let's look at the bottom of our page because we're going to see stuff similar to this on our test. And we need to understand what it means. So when it says what two fractions with different denominators add to be 9/20ths? Who can come up with two fractions that if we add together will be 9/20ths and we don't start with a 20th as a denominator? So I want us all to really think about that one. Here's one way that we could do that. We could start with, well, if I had 4/20ths plus 5/20ths, I know that would equal 9/20ths. Now I can't have that as my final answer because they didn't have different denominators. But what could I do to 4/20ths and 5/20ths? Madeline, I can simplify them. So I could divide out a 4. I could divide it by 4 and say, okay, so 1/5. 4 divided by 4 is 1. 20 divided by 4 is 5. Plus, I could even just leave it 5/20ths because they're different denominators. Or I could divide a 5 out and say 1/4. 1/5 plus 1/4 equals 9/20ths. Because when I give them the 20 as a common denominator, I know 4/20ths plus 5/20ths equals 9/20ths. So I started with the common denominator, and then I simplified to get the different denominators. Does that make sense? I can't put 5/12 plus 4/8 equals 9/20ths. 5 plus 4 equals 9, but 12 plus 8, we can't do that. They have to be a common denominator. So we cannot do that. We have to be able to say 4/20ths plus 5/20ths equals 9/20ths. Here it is with different denominators. I simplified it. Does that make sense? So you're going to do the subtracting to equal 9/20ths on your own. So think of what you could do to subtract to equal 9/20ths. So we have a lot of work time today. Remember, Khan Academy is due tomorrow. Math packet number 2 is due tomorrow. So when you are done with today's assignment, you're making sure you finish Khan Academy and finish your math packets. If you are all done with all of that, come see me. Okay? But this is not goofy time. This is not, we can just socialize until class is done. This is work time. I will let you practice your mysteries of the rosary for reciting mysteries of the rosary. So after you're done with your homework, you could use that time to do mysteries of the rosary. If you are watching this at home, We hope you are well, and we hope to see you soon. Have a wonderful day.